Alright, this video is your Conics Part 2 quiz review. Alright, so number one, here we have the equation for a hyperbola, and we want to find all these things. So, let's start off with the center. The center is easy, it's HK. H is 4. K, since this is y plus 7, it's going to be negative 7. So there's your center, 4, negative 7. Now, your transverse axis, or your t-axis, it's whichever letter comes first. Y comes first, so that means that's your t-axis. Okay, Y is your t-axis. Now your t-axis radius, since your t-axis was y, your t-axis radius is simply b. Remember, this is b squared, so b is 4. Alright? Now, since y comes first, that means it opens up and down. Alright, so since it opens up and down, that means all of our x values are going to be the same. So the x value for our center point and our two vertices is going to be the same. Now to find the y coordinate of the vertex, we're just going to do negative 7 plus 4, which is negative 3. Negative 7 minus 4, which is negative 11. I don't look like an 11. Alright, negative 11. It still looks like negative 1, 1. I'm leaving. Okay? So, there you go. Your center point's 4, negative 7. Your t-axis, since y comes first, your t-axis is y. Since y comes first, your t-axis radius is b, which is just 4. Your vertex, since y comes first, that means it runs vertical. So all your x values are the same for your vertices and your center. And then to get your y coordinate, you do negative 7 plus 4, negative 7 minus 4. Alright? So, that's number one. Let's go on to number two. Alright, number two, I'm not going to try to draw the picture, but I am going to explain it. We want the equation of that hyperbola. Alright, it runs up and down. So since it runs vertical, that means y comes first. So that means this is going to be y minus something squared and x minus something squared because it runs vertical because you have the picture there. Now to find your center point, all you do is that black dot right there, you just simply find the coordinates of that black dot. Okay, the coordinates of that black dot, your x value is negative 5, your y value is negative 3. So this becomes y plus 3 squared, x plus 5 squared. Alright? Now, to get your b value, what you're going to do is you're going to start at the center point and count straight up until you hit your parabola. When you do that, you should get 3. So this is going to be 3 squared. Now, to get your x, what you're going to do, you see how we have this box or this rectangle right there? To get your x, what you're going to do is you're going to start at the dot and you're going to count horizontally over to the dotted line. Alright, so when you count from the center point over to the dotted line, you should get 5 units. So that is your a, and then 5 squared is a squared. Alright, so you have your parabola. I guess I'm going to draw it after all. Center point. Then you have your asymptotes. And then you have this rectangle. From here up, since that's 3, that's going to go, 3 squared is going to go underneath the y because that's counting in the vertical direction. And then, they're going to get bigger and bigger. And then when you count over in the x direction, that's 5 units to the dotted line here. So 5 is going to be a, so 5 squared is going to go under the x plus 5 squared. And of course it always equals 1. So there's your equation, y plus 3 squared over 3 squared minus x plus 5 squared over 5 squared. Now, this 3 is the same as this 3, this 5 is the same as this 5. That's just coincidence. That won't always happen. Because if you look at the very next problem, it didn't happen. Alright, this is just a coincidence that your numbers down here is simply your center point squared. It doesn't always happen. All right, for number 3, we have an equation. All right, it's a hyperbola. We want to find both foci and the eccentricity. Alright, but the first thing we need to do is find our center point. Remember, HK, so -6 and then 3. Now, since x comes first, that means our parabolas, our hyperbola runs left-right. Which means our y values are going to be the same as our center point. So those are both going to be 3's. Now, we have to find C in order to plug in here. Because remember, we can't use 3 because if that's the case, we'll be finding the vertices. We're finding the foci which are past the vertices. Okay? So we have to find C. Remember, C equals the square root of a squared plus b squared for our hyperbola. So this is going to be the square root of 9 plus 81, which is the square root of 90, which I'm just going to say is 9.49. Okay? Now that we have C, we're going to take our center point, -6, and add the 9.49 and get 3.49. Then we're going to take -6 and subtract the 9.49 to get -15.49. Alright? And then remember, your eccentricity is simply C over A or B, whichever comes first. In this case, A. So that means it's going to be 9.49 over A, which is 3, or 3.16. Alright? So that's number 3. Remember, for your foci, first find your center point. Center point, HK. So -6, 3. Now, since x comes first, that means it runs left-right, which means all our y values are going to be the same. So all the y values are going to be 3. Then you're going to find C. C is the square root of a squared plus b squared. That's 9 plus 81, square root of 90, or 9.49. Now, to find the x coordinates of your foci, you take -6 and add C to get 3.49. -6 subtract C to get the -15.49. Your eccentricity is C over A or B, whichever comes first. In this case, A comes first, so it's C over A, 9.49 divided by 3, which is 3.16. Alright? On to the back. Number 4. Doesn't this eraser sound great on the video? Alright, number 4. You have x minus 8 squared over 16 minus y minus 8 squared over 81 equals 1. We want the asymptote equations. Alright, remember your standard form for your asymptote equations is on the front. It's y minus k equals plus or minus b over a times x minus h. So, y minus k, just copy that down. Y minus 8 equals plus or minus b over a. B is 9, a is 4, and then x minus h. And yes, I would take that as the correct answer. You don't have to go any further than that. You could if you wanted to. You're not going to get any extra credit for it. You could if you wanted to, but I would just take y minus 8 equals plus or minus 4/9 times the quantity x minus 8. Why do any more work if it's not required? Alright? So there you go. That's it. Just remember this equation. Just fill it out with your numbers from up here. That's all you got to do. And I'm going to change colors. Number 5. Here's our equation. center slash the vertex. And we want the direction. So center, again, it's just HK. 3, -1. You should be pros at finding the center of these things because they're all HK. Now, your direction. What you want to look for is your non-squared term. So our x here is not squared. That means that it either opens to the left, and you got your directrix line, or to the right. All right, so we know it opens either left or right. Now you have to look at this number. If it's negative, it opens left. If it's positive, it opens right. Since it's negative, that means it opens left. Alright, so your not squared term means it opens left or right. Go to this term, if it's negative, it opens left. If it's positive, it opens right. So, since it's -16, it opens left. That's all you had to do for that one. All you had to do for that one. Remember, go off your non-squared term. All right, number 6. We want the focus point. Remember, there's only one focus point for a parabola. And we want the equation for the directrix line. All right, so again, x is not squared. And the 8 is positive, so that means it opens to the right. So that means it looks like this. Okay? It opens to the right. Now, we want to find our center point, because we need to find that to find our focus point, which is out here. Okay? So our center, even though it's not required for the answer, you have to find it to get the answer. So our center is -4, 1. Okay? Now, since it opens to the right, that means our y values are going to be the same. So our center point, you just copy your y value up to your focus point. Now what you have to do is you have to find p. Well, if you remember, this number here equals 4p. So 4p equals 8, divide 4, p equals 2. Okay? Now, since it opens to the right, we are going to take this center point, which is -4, and add 2. -4 plus 2 is -2. So our focus point is -2, 1. Now, since this opens to the right, that means our directrix line runs up and down. Well, a vertical line, you can't write in the form of y equals. You have to write it in the form of x equals. Okay? So we know our directrix line is x equals something. How do you get that something? Well, since it opens to the right, you're going to take this number and subtract p. Right? So -4 minus 2, -6. The equation for your directrix line is x equals -6. Alright? Remember, since it opens right, we did -4 plus 2 to get our focus point, -4 minus 2 to get our directrix line. If it had opened left, we would have done the reverse. Okay, we would have subtracted to get our focus and added to get our directrix line. Alright? So that's it for that one. Let's go to 7. We'll do 7 and 8. Alright, number 7. It says, choose the correct conic section that is described by the following definition. So make sure you wrote down the definitions. The set of all points whose distances from one central location and a special line are always the same. Now, the key word here is and a special line. Because think about it. All the points from a given point that are the same distance from a given point would create a circle. But since we have that and special line in there, that means that you have your given point and your special line, so that means you have a parabola. Okay? So number 7 is a parabola. Alright, now number 8, we have to identify what this is. Alright, I'm going to erase everything now that is not important to finding out what this is. Alright, since these are different, and you have one positive, well, first of all, you have 2 squared terms. Alright, so you know it's not a parabola because you have 2 squared terms, but it could be a circle, an ellipse, or a hyperbola. So, since both of these are different, and one's positive and one's negative, that tells you that it's a hyperbola. Okay, that tells you that it's a hyperbola. Remember, a circle, they'll be the same. An ellipse, they'll be the same but different signs. And in a hyperbola, they'll be completely different. Okay? Different numbers, different signs. So this is a hyperbola. Alright? So that's been your Conics Part 2 quiz review. Feel free to watch this as many times as you need to. Make sure when you come to class tomorrow, you're ready to take the exam. See you tomorrow.